Hi, my name is Renee Teate, and I'm the Senior Director of Data Science at HelioCampus. Today, I'm going to talk about how do predictive models work. So what does it mean to train a predictive model? And I'm going to use machine learning model and predictive model interchangeably throughout this presentation. So our goal is to show an algorithm, which is a combination of code and math, enough examples or instances of the things that we're trying to predict that it can pick up on patterns in the data and use those learned patterns to make a prediction for an instance it hasn't seen before. So we're going to explore all of the available data, create a data set of past examples with known outcomes, and process those through the machine learning algorithm, keeping aside a holdout set of records that we can then use to test the trained algorithm. So once the model's trained, we can have it make predictions on that holdout set, the records it hasn't seen yet, to see how well it performs. And since we know the outcome of those, we can then measure how well it predicts. We then make tweaks to the input data and settings of the algorithm, and we train and test it again until we get a model that we're confident we can make good enough predictions with for the task at hand. And people are making those decisions, data scientists, about what and how much to adjust it, in what ways to adjust it, and how much to adjust it, until it's considered good enough for the particular application. And then the model is used to make predictions in real time. Meaning that we didn't know the outcome when it made the prediction. And then after those outcomes come to pass, then we can evaluate whether that model was correct or not. So here's some data. Let's say we have a bunch of data points. It's in 2 dimensions. So you can see an X and Y axis here. This can represent anything, like the size of the house versus its sale price. We can fit a line to this data by trying a bunch of different lines and measuring how far each of the data points is from each of the lines, and then pick the line with the least overall error, where as many dots as possible fall as close to the line as possible. This fitted line is a model. So now if we know the value of one dimension for a data point, we can use this model to predict the value of the other dimension. So for example, if we know the size of a house, we can estimate its price. Now, of course, there are other factors we're not considering, like the age of the house, the location, etc. So our model is likely not a very good one if we're just using one input feature to predict the result. But it is a model, in this case, a linear regression model. Another kind of model is a classification model. We might have lots of data points with different characteristics that we label as falling into one group or another. So in this case, there's an orange group and a blue group. Maybe these are donors, and the orange ones are athletics donors and the blue ones are non-donors. And so here I'm showing the data points in 2 dimensions flat on the screen, but you can imagine it in 3D like a cloud of points. And in some models, there are hundreds of dimensions. So that's why we use computers to help us train these models, because it goes beyond what humans can effectively visualize or calculate by hand. So what we're trying to accomplish here is to detect the patterns that make a point more likely to be in one group or another. So after looking at the input data, the algorithm will try to detect patterns and come up with a model for dividing the 2 groups. And we'll have to evaluate how well it did. So how well does this multi-dimensional separator distinguish the 2 groups? We may try many variations of input data and even different algorithms and evaluation metrics to come up with the best model to help answer our specific question. Then when a new data point comes in, we can use that model to determine which group we think it most likely falls into. So in our example, this dot came in on the side of the separator that it has mostly blue points. So we might say that this person is likely to be a non-donor. So this might be, another point might come in that might make them more likely to be an athletics donor and prioritize them for a higher outreach or something like that. So what are some of the different ways we might evaluate how good or how useful a model is? We might check how many of the instances that we tested it with were correctly classified into one group or another. We might look at how far away a numeric prediction is from the actual value once that occurs. In cases where the model was wrong, in what ways was it wrong? And what features were most helpful to the model to be able to classify the unknown value? So out of all the different columns of data that we inputted in, which one was the best at separating the people into one group or another? In higher ed, which is the industry I work in at HelioCampus, Here are some examples of predictive models you might see in our industry. We might have time series models where we're looking at counts over time and predicting how many students will matriculate next semester based on counts of applications, deposits, and enrollments per week, for example. A regression model could be used to predict metrics such as a student's future GPA or the size of a donor's next gift. A classification model can be used to determine the likelihood of an applicant to enroll, or the likelihood of a first-time student to retain for 1 year and still be enrolled a year later, or for a student to graduate within 4 years, or to make a gift to the institution. So this was a very quick overview, but hopefully it helped you understand what a predictive model is. And you can feel free to reach out to me at HelioCampus or on Twitter. There's my email address and my Twitter handle. And I look forward to talking with you.